Okay, I think you should have got some notification that it's recording, in theory. Yes, William, how are you? Long time no see. I think Zach also just, Zach is coming in. Kim as well. Okay. Yes, William, you were mute, yeah?
I'm sorry. Hello, everyone. Hey, I'm Mohammed. Great to see everyone. It's been a long time. It's been a while.
Yes. And just like you, Zach also, it's been a little while. It's good to have you guys back. Zach, how are you?
Nice to see you, Isaac. How you doing, my man?
Doing great. Good to see everyone.
We missed you, Zach. We missed you, William. So I hope we're gonna catch up now.
Absolutely.
Ryan, sorry, William.
Do my best. Yeah.
Thank you. And Ryan, how are you?
Excellent. How are you?
Good, good, good. We also have an old friend of mine when I was working with the United Nations on a project in Jordan. We have Mohammed Arabiat. You know, we are probably 200 million Mohammeds in the world. So this is Mohammed.
Minimum.
Yeah, minimum. You're right.
Hi, Mohammed. How are you?
Welcome, welcome, Mohammed.
Yeah, since I think 19 years back to the project of the UN and ITC.
That's right.
Yeah, but it was a good experience that time.
Yeah, it was a very nice experience. I really loved the ambience in Amman, the shisha, the nice food, the hummus.
Yeah.
It was really good.
Yeah, and we are willing that you can come sometime soon.
Yeah, let's do a AI automation workshop or something.
Yes.
Yeah.
That's a good idea.
And I think we have also some nice people that are having here a first time. Dr. Charity, welcome. Very fresh. If you want to say a few words, you're more than welcome. If you're shy, there is absolutely no problem. And I think, hello.
Hi. I'm happy to be a part. I'm just sitting back to watch and learn from the pros because I literally know zero, and I'm at the intimidation stage. So,
Oh, no,
I'll
no,
just
no.
sit back and listen and learn. But thank you for having me.
No, pleasure, Charity. Just for context, and maybe some of you guys who may be intimidated, I was a sports teacher. You know, I just understand. Give me a ball. I kick the ball to the kids. They play. I get paid. I go home. You know?
That makes sense. Thank you, William.
Okay, cool. And then Justin, you want to say a few words? Justin just joined us. He's near Los Angeles. I forgot the city, but I think Justin has a very nice local business model that we can learn from, all of us, that it concerns medical and health sector. I don't know if just comfortable. You're very welcome to say a few words.
Yes, I just have some background noise right now. Give me a few moments.
Yes, sure. Take your time. And then we have Miyami-san. Miyami-san, dozo yoroshiku from Japan. If you're comfortable, you're welcome to say a few words. Otherwise, we're happy to have you. That's probably the most far east we have in our community in Japan. And I think I covered pretty much everyone. Cyrus, welcome again. Sorry for the earlier meeting, Cyrus. Okay, good. We probably should give it a go. Now it's Zach. I think this time we got it right. Is it 1 p.m. in Eastern time? I think William, you're also in Atlanta.
Yes, that's correct.
Okay, excellent. I'm gonna start sharing my screen, and then we will keep 15-20 minutes at the end to discuss. Because this is kind of, I think it's the most important theme that we need to calibrate between us and understand so that we can offer the best service to our enterprise clients. And it's a little bit weird. It is kind of an unusual way of thinking, because especially for business people, we often delegate this step or we don't pay attention to this step, but it's really super important. And I'm going to load here the side here. And sorry, I had my way to record this. Let's try to do this way. Making some arrangements, visual arrangements. Eli, is it big enough, the slide here? The slide that appears?
Yeah, but no, I can see that clearly. If other people are having issues, will you just say cannot see it? But other than myself,
Yeah, please.
I can see clearly.
I'd like to
Just raise up your hand.
Yeah, because I'd like to keep the window where we see our good people here in the video and give as much space as possible to the presentation as well. Okay, cool. Someone wants to join. Let's just accept this.
That may be me switching devices, Mohammed. I'm sorry about that.
Sorry?
I'm switching devices. I apologize.
Yeah, no worries. I'm also trying to figure out my way now with this setting. There is somebody who is waiting to be accepted. I hope I can.
I think that's me.
Oh, that was you. Okay, cool.
Yeah.
So we're good then. Welcome, guys. Again, it's good to see the community growing. And like I was saying, even if you missed earlier sessions, I think this is a good piggyback session, or how you say in English, hitting the road running about this subject. And this subject is about the data track. We have 3 tracks that we splitted the program into three tracks to keep it focused and more and better deliveries. This is the initial track that we did. Actually, we started with you guys, the early adopters, that we call the data track, which is about developing a data product, a system. So we've done the 5 minutes intros, and then the second point we will just spend another 5 minutes is a small update of our data value chain. And the data value chain is kind of our strategic vision, and also it's the strategic vision that we want to sell to our corporate and enterprise clients to make them realize the value of their data. So we have updated a couple of things, and just we bring it back to refresh our memory. And then we're going to dive into what is a database structure, DB for database. And I will highlight first that with all these AIs and automations and bots, actually what we need to remember is that we need to remain and focus on being human-centric, because there is nothing else than us, the humans, in all these technologies. At the beginning of a value chain and at the end of a value chain and in between, it's always a human that proposes something and another human that consumes it. And in between, we use AI, bots, robots, water, stone, gold, whatever is in between us. But the beginning and the end is always a human. And then we will review the classic, what we call relational tables, is how you structure data in a database between different entities. I will just give you a refresh on that. And then we will dive into what we call the abstraction tables. And this is the subject that we want you to be exposed to. And even if it's a little bit confusing, because as a first interaction with this concept, this is the most powerful concept for us to grow our enterprise clients database to the next levels. And we can do then another session more hands-on and more in-depth on abstraction tables. But today, at least we want to engage you guys in a discussion, questions and answers, and give you a first snapshot, level 1. And then we will take at least 10 minutes for question and answers. Those who have a bit more time, we're happy to stay a bit longer, up to a half an hour, to answer more questions. So let's kick it off. And I think somebody wants to join, but again, it's probably Zach. I hope it's Zach. Sorry, guys, I just double check if we're not missing someone. I'll just stop the sharing for a second and get back to this. Yes, there is. Yeah, Zach was waiting. The second Zach. Zach, are you duplicating? Yes. Okay, good. Let's go back to presenting. Here we go. Okay. Setup is back. Let's refresh our memory about the data value chain. And what we did about a month ago was to show you guys this journey. It's really a journey, and it's not a short-term and quick win journey. It's really about digital transformation and strategic adoption of AI and automation in the business's DNA. Like really, how do you infuse AI and automation in your business instead of just picking up what we call the popcorn AI products that are appearing and everybody thinks that it will do the job. But when we work with enterprise level, they are regulated, they have long-term visions, they have sensitive data, and we can't just put data anywhere on the cloud like that. So that's what we want to offer. We want to offer a more stabilized way, a more owned way, where there is 100% ownership of the data and the infrastructure. This is also the nice discussion we had with Justin, where everything is coming together in the market today, the hardware, the software, the people, and the knowledge, for us to deploy AI and automation in a way that is owned by our clients, instead of a vendor-locked, cloud-based red ocean market that already exists. So in that perspective, for that niche market, we are all starting from the bottom left. Even for our own, we have data, but often the data is either in physical forms, in papers, in photos, in videos, in sound files, in legacy databases. Sometimes we have it in CSV file, Excel files, PDFs. Sometimes we have some old websites where the data is not structured. Sometimes we have structured websites, but they don't have an API. There are various ways where the data is split, and this is what we call the chaos corner. That's where we start. And there we start with our RPA bots with RTILA to digitize and get the data into CSV, what we call our organized CSV, and then we bring that data to the next level in a Google Sheet with our command Google Sheet, and we will do courses about that. And then we can kind of go through the first phase, which can last 1 to 3 months, which we call the scrap end. We're scrapping the data, we're mining the data. And then the second phase, just as a recall, is where we start to correct the data. We format it, we enhance it, phone numbers are put properly with the international extension, zip codes are separated from address, the city goes in the city field and all that, so that the data can become analytically acceptable and reachable. And then we start to enrich the data, and then we work on the presentation. That will be phase 2 of our program. And the phase 3 for our customers and us is how we build a digital product out of that structured data. So we have the back-end SaaS that Eric is enjoying already, and a few of you are going to receive it also this week. So the AI back-end SaaS is what is going to bridge us from the very hard work that we are doing in collecting, scrapping, modifying the data. And now we have a data container that is based on PostgreSQL, which is one of the best databases that is open source and free to host, for us to grow our data set into digital products, be it training our own AI model or an AI model for our customers, or building a front-end SaaS, a mobile app, and actually building our own Apollo or ZoomInfo for Germany, in your case, Eric, or for the medical industry in America, for you, Justin. We can build our niche B2B leads, systems, and then monetize them. So there's so many ways, or help our customers monetize their data sets. So that's the idea of growing towards the upper section of the graph. Growing up, it means we structure the data. We came from down where the data was disorganized, and going towards the right side, it's not only going in time, but it's also going in the level of enrichment of the data. For example, we started with, we only had first name, last name, and location. But going towards the right side, we know the family situation, the socio-economic category, the location of our customer or partner, and then we have their email, their social media profiles, and we may know their preferences. They like red color, they like sweet over salty, they prefer entertainment on the weekend, or they work on the Saturdays. Like the idea is how can we catch those data points that will give us a better picture of our market. And I will show you later on why it's important in this age of AI. So this is our data value chain. And to reach this high value monetization that is on the top right, the first step, and that's why we are insisting on it, is you better not start with the wrong database structure. Because if we start, or our customer starts with an incomplete database, that means we're going to spend money, time, and resources. We're going to build a certain building, and 3 months, 9 months, we say, oh no, it was not supposed to be a villa. It was supposed to be a building with 7 floors and multiple apartments per floor. And we didn't plan the lift, and we didn't plan the stairs, and we didn't plan the garage and the parking. So this is really like the civil engineering side of before building, we draw an architectural plan. And this is the architecture of the database. It's exactly the same thing. We're building a business. And number 1, define the structure, define the database model. That's what we're going to do today. We will take some questions, of course. Now I just go through the recap. So the next point we said is we have to remain human-centric, and really always put the human at the center and at the periphery. At the center, at the periphery, at the extreme, in the right, in the left, in the top, like everywhere, we're going to be dealing with humans, multiple humans. So when you look at all our data sets in any business, whether you have a CRM, a lead generation, or a customer database, it's about people first. And we as humans, we are organized in different ways. The most, the no-brainer, the most initial way, natural way of when we come to be born, we usually group by ethnicity or culture groups. And then when we go in life, we unite with other people and we form associations, nations. Like this is kind of my map. Me, Mohammed, I'm born in a Moroccan family and North African culture, and everybody looks like me in my culture because that's where we are born. And as I grow in society, then I start to mix with other people, and I find affinities, and we together as humans, we become a nation. The Moroccan nation, the French nation, because I'm born in France, so I carry both nations, Morocco and France. But also I may join a political party. I'm more like of a centrist. So I may have friends, and then we join as a political party. We may join as brothers in faith, sisters in faith. I'm from an Abrahamic perspective, more on the spiritual side, but basically a Jewish, Christian, Muslim background. And that may be important to me, so you may want to know that as my provider, because you may want to wish me a happy Hanukkah or a Merry Christmas or Eid Mubarak. And the same for Hindu, Buddhist, or whichever affinity a person may have. And then I may belong to a social group, and we often come together as sports fans. I may support the Lakers, and then in the British Cup, I don't know, Eli, who you support, but I like Liverpool. So maybe we're in the same group, maybe we're not.
Ah, now I like you. I didn't like you before, but I do now.
Yeah,
Now I know
so you
that
see-
you're a Liverpoolian. You're a cool dude.
Yes, and Mo Salah is playing there, or at least was playing there, so I like Liverpool. So now we have an affinity, Eli, in our database. We're both related through Liverpool support. And then we can come together also as a company, as a cooperative, as a corporation, and we form a company, and then we work together. Now, why am I saying this? Is because this is really to remind you that whatever we are going to collect as data, be it a table, a field, you always have to keep in mind, you and your customer, how does that relate to the human? How is this going to enrich my understanding of my human partner? Always, always, always. It can be a date, a document, a contract, a picture, a sound file, a video. How does it relate to the human being? Because I want to code that relationship in my database, because maybe 5 years ago, all this blob of information, we were not able as humans to pick it up and connect the dots. But now we have AI. So if I can collect all this and I feed it to the AI may tell me, Mohammed, hey, you didn't notice, but I noticed that this kind of people, they associate in this kind of area, in this kind of moment, and they all drive red cars, or they all drive Harley Davidson bikes, and they drink this kind of beer in this location. So AI will allow us to figure that out if we, as business people, we have created the container and the business processes to capture that data in the first place. And that's why I really insist on this part. Now, I think you got the point. We can extend it, but let's look at our classic approach where usually everybody starts from in terms of building a database. We often build databases in what we call the tripod or the three tables, where you have two entities, for example, a student table and a course table in a university or school setting. And then, so student is an entity type, course is an entity type. When I say entity type, just look at it as a table, a Google Sheet table or a Google Sheet. We have one Google Sheet for students. We have one Google Sheet for courses. Now, the relationship between the two is what we call an enrollment into a course. A student enrolls into a course. Now that becomes a third database, which we call the relational database. That's what relational tables means. It's very simple. It's when a human is going to interact with something else. A course, a product, a company, a software, a service offering, anything that you may have, a book. They go to a library and they borrow a book. You need to create a relationship between a human and a book, and that's called, I don't know how you call that, borrowing of a book or allocation of a book. That will be the third relational table. So how we go about it is that we always create three entries in our three tables. For example, Mohammed here, I have an entry as a student. I have a student unique ID number. This is very important, guys. With your clients and your data, you always must have a unique identifier column for every entity, because I cannot have, so I was saying there's Mohammed Esfi and there's Mohammed Arabiat in this call. Unless I give a unique ID to Mohammed Arabiat from Jordan and Mohammed Esfi from Mauritius, at one point one of our team is going to mix it up. He say, oh, it was Mohammed who enrolled in this course. Which Mohammed? So
the double N one.
Sorry?
The one with the double N.
That's even more confusing. Yeah. No, but thank you. So even when it's obvious, a unique ID is really a must, and you must insist on it to always create a unique reference. The main mistake that people do is that they say, let's do a student ID and we're going to use the initials of the student, ME, and that will be the unique ID. No, because Mohammed Esfi is ME, but then also you can have Maria Esteban. She will be also an ME. And then we're going to mix up our unique IDs. So very important, but you got it. My unique student ID. Just like an SSN number in America cannot be duplicated, because in the US you would say checking out. Yes, checking out a book. Thank you, Zach. But also in the US, no two American citizens or American residents can have the same SSN number, because then in the database of the government, it's going to create a lot of problems. So the same ID here, a unique ID. So you have my entry row as Mohammed, my first name, last name, my email. This is me in the table of students. And then the university has different courses. The courses have a unique ID as well. So the AI automation course, which is given by this instructor and not the other instructor, has this reference. And then when I enroll in that course, the relationship is also unique. So the relationship here of the enrollment ID is a specific unique ID that links my unique ID as a student to the unique course ID under a unique enrollment ID. This is how you build proper databases and avoid duplication and can pull back all the data. And then you can add statuses and columns in that table. For example, an enrollment can have a different status. I enrolled, I was approved or not approved, I paid, I didn't pay. I can take X subject or 3 or 4 subjects, and then you got the point. This is the classic way. And for those of you who this is the first time, please go to school. And in our school, we have a course on this. We explain what is an entity in the database, and then we explain entities and attributes. So if the entity table is students, then the student will have a student ID, and then what we call a unique key. The unique key is the student ID. That cannot be replicated. The first name can be replicated. There can be many Mohammeds. There can be many Does, many John Does. But the email also can be unique. So these are the concepts you need to master. And then after you master that, you have here more information on the relationships. And the relationships, they have directions. It's very important that you understand the directions between relationships. For example, you can have what we call a one-to-one relationship between two tables, which is very useful. For example, I cannot have a car plate of a car that is associated with more than one car. In the database of the car registry in my country, it will create confusion. I think the only country that I saw allow that is Switzerland. But then you have to declare that you're putting the car plate on your Porsche, but then next week you're going to put the car plate on your BMW. You have to declare it, because otherwise when they give you a fine, it's one car plate, but you have two cars. So besides Switzerland, almost all other countries, they only allow a one-to-one. You have this on many types of databases. So the best example I could find is the car and the car plate. One car can only be associated with one car plate. But then you also have instances in databases where you have one-to-many. For example, in a hospital or in a clinic, Justin, in your field, you can have one doctor serving many patients in one discipline like cardiology. But you cannot have the same patient going to see two cardiologs at the same time. That will create a mess in the database. So this is a one-to-many relationship. One doctor can have many patients, but one patient can only have one doctor in one discipline. And then you have the cases where, like the university example I told you, where you have many-to-many. Many students can enroll in many courses. Many courses can be associated to many students, and the students can choose and go in between courses, and the courses can be disabled or activated to students, and you have a many-to-many. And if you pay attention, guys, there is a small sign there. You see that tripod in two ways for the many-to-many? That means that there is many-to-many going this way. When it's many-to-one or one-to-many, from the side that is the many, you have that tripod going to the side that has only one string. And then when it's one-to-one, there is no tripod. It's just one single line, dot to dot, one line. This is how you call it the mapping or the nomenclature of relationships. So these are the basics that you guys really need to know and master, because this is what you will engage as a discussion with your customer. You will tell him what kind of relationship are you going to have between a staff and a vehicle in our company, because the vehicle is an asset. What kind of relationship? How can they book it? Can one staff book more than one vehicle or two? And so on. So all these questions, they will be very important in your database structure. And we can dive onto this, but this is what many developers, they know it, and they will do this for you, and they usually get it quite right. Now, let's go to the next level, because we want to create even more value. And why I am saying this is because we have a vision. So this is our vision, you remember? We are scraping data. We're spending a lot of time and energy and mental investment into scraping data, enriching it. We want to make the maximum money out of it. And why not creating our own Apollo, our own ZoomInfo in our own niche, and monetize that? So to do that, we need to design a database structure that will allow our data set to grow and be enriched to that level where we can monetize it. That's why it's important here. And the shift to allow that kind of business development is to move from relational table to what we call abstracted table. And that's the next point that I'm going to show you. But let's take a specific use case today, because we talked about student and courses. We talked about car plate and cars. But let's look at a B2B lead SaaS. Let's say we want to build a B2B lead SaaS in Germany, in America, for the medical sector. Yeah. So the three tables, it's not enough, because that will not give me enough analytical, enough filtering options for my customers, because my customers, they may want to ask me, Mohammed, I want to find every C-suite position, CEO, CFO, and CTO, in this location between 2022 and 2024 in a company that have 5 million revenue in the state of Nevada. Pull me that data. If I only have 3 tables, I will not be able to pull that data. If I can't pull that data and present it, I cannot charge them for that and be paid for it. That's the whole game here of improving our understanding of database structure. So how can we upgrade our database structure from, let's say, self-use in my little company to the level where I want to sell that level of analytical data? And that brings us to the next subject, which is abstraction tables. Now, this concept of abstraction tables is very foreign to the human mind, because machines and developers, they are very familiar with it. But we business people, it's almost like this becomes now a Martian language. It's extraterrestrial of nature. But it's a higher dimension of structuring our data, and I will try to explain it the best way I can, and we can engage in questions and answers. So the idea of abstracting the initial table that we would have. So if we were going to build initially a B2B lead database, I would have created a database table or entity that is called people or natural persons, physical humans. And then I would have created another table that is organizations, a business, an association, a cooperative. And then I will have coded some roles like director, shareholder, investor, teacher, mentor. And then the third table, which is the relational table, is what links the natural person to the organization. That would have been my first reflex based on the first knowledge that I shared. Now this structure needs to be complemented with additional tables that we call abstracted tables. Now, what would be these abstracted tables is what we could call a table that we call the party. So to benefit from the power of AI and automation, AI is able to understand concepts. And AI likes that we standardize things. Like we standardize relationships, we standardize types of entities, and we standardize groups of data so that the AI model can build a concept and relate it to a table or relate it to a group of data. So for example, if we say, yes, Mohammed is a human. Mohammed as a human can be a teacher, can be an employee, can be a shareholder, can be a director, can be a painter, can be employed, not employed. That's good. That's one set of qualification that we can apply to the human, but we can also abstract that and we can say Mohammed is a party. In a relationship, Mohammed is just a party, a generic party. Eli, who is Mohammed's partner in this venture, is another party. It doesn't matter yet how Mohammed and Eli are relating. It doesn't matter yet at this level if Mohammed and Eli are humans or bots or legal entities or a stone. It doesn't matter. It's going to be a party to the relationship. Therefore, we create this abstraction level that we call party, where a company can be a party, a human can be a party, and the day that we have aliens join us, we're going to add the aliens as a party as well. And they can be of any planet and any type. But basically, that's the idea of abstracting the parties. It can be really independent from the nature of the actual party that we call people or organizations. So now that we have this party abstraction, I need to create an entry for Mohammed or John Doe. So that will be the first entry, and it will have a unique ID. And that John Doe from New York, the type is that he's a human. And the type will go and pull to my natural person table. And now I can relate this party to the human table. And then I will create another party, which is the company where John Doe is going to have a job. And that company is called Solar Inc. from Nevada. So Solar Inc. is going to be another party. And Solar Inc. is of a type organization. Does it make sense? This is how we can contextualize a party, because a party initially is generic. It's just a party. And now we relate it to the initial tables that we think of as business people. So now we have the abstraction of party. Then we abstract the relation itself. Now, instead of just saying Mohammed as a natural person will play a role in, John Doe as a natural person will play a role of director in an organization called Solar Inc., we say party 1 and party 2 come together in a new table called relation. And this relation, so we're going to create an entry in the relation table that concerns this party that we want to bring together. And this relation, for us human, we need a name because it doesn't make much sense. But let's call it John Doe at Solar Inc. That is this relation that we are creating. And this relation can actually outlive the parties. And this is what AI can help us with pulling the data. A relationship can be paused, can be resumed, can be cancelled. So when we build abstraction, we can measure, we can record interruptions, recovery, and other data. So now we have a relation table where we create this relation, and this relation has its unique ID. And then we have a third table again that we call a junction table between the relation and the party. So for example, for the relation that we called John Doe at Solar, we're going to create two entries in relation party. The junction table is that we're going to create a John Doe from New York is going to be a relation party entry, and in his relation party entry we're going to code his position as a director. We're going to code the direction of the relationship. This is important because let me give you an example of relationship direction. For example, Eli, you have a daughter, right? Like me. So the guardianship relationship between two humans, that is a father and a daughter, the relationship is called guardianship. It has a directional responsibility, which is from the adult to the child. It's not the other way around. It's not the child responsible for the adult. Yeah. So the same with teacher and student. The movement of the knowledge goes from the teacher most of the time. It's also bidirectional, but most of the time the responsibility for which the teacher is going to be paid is to transfer from his knowledge to the knowledge of the student. So we need the directional relationship, and that's why we code it in this table. And we say here that John Doe is the two. He's receiving the position of director. So we create a director position in this relationship here. We called it directorship. We said that this is a generic abstracted relation that we call directorship. Now we're going to specify the direction of the directorship by saying that the relation party John Doe is the relation is going to him. That's the direction, the role ID. And then I even code it in text for us as humans to understand. And then we give it a start date. He got his directorship position and he started on the 1st of April. Now we need to code the other way around, which is we need to code the relation party entry where the company has given a position to a person. Now we have to code that perspective as well. So now it has another unique ID. It has another party ID, which is Solar Inc. It has a role. We can put a role like, for example, employer or something like that. We put a direction. The direction is that this company gives the role of director from the company. So it's from the company to the individual. The knowledge goes from the teacher to the student. And it has a start date as well. Sometimes you may think the start date is the same, but sometimes it's not. Sometimes a student is enrolled in the course. A teacher is enrolled in the course before the student is enrolled in a course. So sometimes the dates can be a mismatch. It's not always that a relationship between two people started at the same time. And these are the subtleties that we can catch in the abstraction level. So it's a little bit ambiguous at first, but let me give you a live example to try to crystallize it a little bit better. Let's look at the classic way. The classic way, Eric, sorry, I put it for you in your database so you can train on it, but you can delete it after the course as well. So Eric, if we had a John Doe in our database, I create a John Doe entry in my table called natural person. Ryan, this is very relevant for your database structure as well. So you may have an employee or a candidate that is a natural person. We code their data. This is John Doe. He's born on this date. He's a US citizen. He lives here. I have his ID. I have his photo. And I have a lot of data about John Doe here. And then John Doe is going to get a role. And I'm going to say, yeah, he will be a director. So this is like the basic way that we do. And then he will be related to an organization that I pull from my organization table. And then this is my third table relationship where I say John Doe works at Solar Inc. And he started on the 1st of April. This is the classic way that I presented at the beginning. Very easy to do. Now, the abstraction level of this relationship, and this will not be sellable as a lead generation SaaS. It will be good for us, for our own business, but let me code it now. So in the party table, I created 2 entries. I created John Doe from New York, and John Doe is of type natural person. Then I created an entry for Solar Inc. And forgive me, I speak fast. So this is the abstraction entry of the company, Solar Inc., and it's of type organization. Now I have abstracted my parties. Then I went into the relation table and I created a new relation that started on April 1st. That is John Doe at Solar Inc. And the type of relationship is directorship. The type of relationship between Eli and his daughter, me and my daughter, is parentship or guarantorship. If we want to record a wedding, then it will be Maria Ernest and Mohammed Arabiat, and the relationship is marriage or wedding and a date. So please keep your mind very open, because it's all about relationships between humans, and if it's not humans, it's a group of humans, and we will always be that. And there's always, unfortunately, to everything, there is a beginning and an end. We come to birth, we come to die. We get married, and sometimes we are either separated from our partner by death or by a divorce or whatever it is. We get a job, we get fired, or we resign. So unfortunately, there is always this starting date, finishing date, and I code it here as a relationship. And then I go to the relation party and I make my 2 entries. Again, this is a lot of entries. So it may look like extra work, and it may look like extra data in the database, and it's going to blob our database. Actually, no. The small additional data that it creates, but it gives us, it could be a rock. Yeah, yes, you could have a relationship with a rock. So what I was going to say is the relation party has to be coded as well, and this is where we code the direction and we give it a name. And this relation party can evolve over time, even if the relation itself remains active. And also we can create, we can codify our relationships. If you want to go in details, for example, if I work with accounting or regulating firm, I will customize the relationship for my customer. I say, oh, you guys are in accounting, so we're going to create auditing relationship, regulatory, investor, shareholdership, and all these things to match that business model. So we usually would create this relation type catalog or role catalog. So this is what I tried to crystallize for you. We went from 3 tables with 1, 2, 3 entries to an extra 3 tables with an extra 6 entries. That's a lot of additional data. Now, before we go into questions, I want to share with you the why and the benefits of this. Is that, remember, we are in an age of AI and automation, so we can get out of our data more than what we can understand as humans. And if we can make this effort of abstracting our data and creating that containership of abstraction, we are getting the best of the possible monetization potential of data as of today. And these are the main benefits. When we create a party abstraction, we create a unified abstraction that can represent different entities, both human and non-human. And it actually can support millions of heterogeneous entities of different types. We can code millions of them as parties. Like you said, Eric, we can make stones parties, we can make a car, we can make a robot with AI, artificial intelligence, can be party to a relationship because it will have autonomous decision making and it may take responsibility. Thanks, Zach. So why it matters is because if we don't separate the logic between different types of parties, then the AI and the LLM models, they will have a hard time to conceptualize the relationships unless we give to the AI this level of abstraction. And then also the second big advantage is that we are creating a very rich relationship model. Like I was telling, we can code the relationship of parentship. We can code the relationship of wedding, employment, course, teaching, car rental, doctor, patient, insurance company, and how you call it, a trustee, trustship. Like any kind of thing, investor, investee, accelerator, startup. Any kind of relationship with this kind of model, we can codify it in a beautiful and deep, multiple depth level. And also, it gives us multiple dimensions to the relationship. It has a temporal dimension. It starts, it pauses, it ends, it resumes. It has a location. It can capture many-to-many relationships at a granular level. And that will allow us to reply certain questions. For example, who was the director of this company in Q1 of 2022? And I want the response fast. I don't want my database to take 5 minutes to pull it because it would have to go to the table of the human and then find that, oh, it's related to a company, but it's related to many companies. Which one actually of these companies had a relationship that has Q1 of 2022? And the logic goes in too many directions. But here, because you can lock into a relationship that belongs to March or Q1 2025, the AI goes there and then finds that party and then goes and finds the other parties and pulls you who was director of this company in Q1 of this year. But also it can make a differentiation between he has been a director, he was a director, he's no more a director, or he will be a director, or he may be a director again. And you can see here the subtlety of the level of data that we can encode here. And then third point, and I'm going to try to go fast to allow you for questions, is that we have a total flexibility in terms of roles that a human can play or a party can play in a relationship. For example, Ryan. In a university, you can start with me, Mohammed, being a student in a course that Ryan is giving as a teacher in the same university, in the same relationship. It's a relationship about Ryan and me in the University of whatever, Pennsylvania. This year, I'm the student, Ryan is the teacher. The same relationship between me and Ryan. Next year, I will be the teacher, he will be the student for another course. If I hadn't done the abstraction level for the relation, it is still a relation between me and Ryan, yet the relationship is of a different nature at a different time about a different context. And we can have two relationships between me and Ryan at the same time. I can be his student for course 1 and he can be my student for course 2 at the same time or sequentially. Now this depth of relationship will not be captured by the classic three-table approach, but it can be captured by the abstraction level approach. And finally, the fourth advantage is that query is faster and you get a super high level of analytical readiness. You can pull dashboards, you can pull trends, you can pull precise position, and you can create heat maps and overlaps. You can say, for example, which roles are overlapping in a company at a given time for a given responsibility. When did the person become inactive? List in all the organizations. Yeah, you can quickly pull all the companies where Mohammed has been playing any role at any time. And all this data can only be made if we have, all these queries can only be answered if we have abstraction level. So I hope I didn't confuse you too much, but let me give you the motivation why it's important. And we can call it the four-wheel drive, the 4 Ws. You want your database to be a true four-wheel drive and go into any terrain, in any context, in any business vertical, in any business industry, medical, financial, banking, insurance, education, whatever, travel, transport, trade, e-commerce, anything, I need to be four-wheel drive with my database structure. So what are the four-wheel drive? What are the 4 Ws? Is I want to be able to answer and to know who and whom. Who is related to whom, and who is giving what to whom. Who is teaching what to whom. Who is selling what to whom. Who is investing money in whom's company. You know, there's always this who and who. I want to really be mastering that part. And then there is the other W, which is when and where. That's the context. A relationship is going to happen somewhere at some point. It's going to start and end. It can start in New York and it can end in Los Angeles. We can get married in Paris and we divorce in Tokyo. You know, there are so many dimensions to relationships and it's important to code them. And then there is the what and the how. What did I do? I bought a car. That's the what. I got a car, a BMW, whatever, you know. How did I get it? It was delivered. I walk into the shop. I pre-order it. How did I get access to the what? To my product, to the service. It's a course. That's the what. How did I subscribe to the course? E-learning or physical presence? So the what and the how. And then where it becomes very valuable with AI Automation Age is that we can now bridge into the why. Why did this happen? Why did Eli choose to buy this car? Why did Eli subscribe to this course? Why did Eric travel for holiday to Mauritius? You know? Why did Justin buy a MacBook and not an IBM computer or whatever? That's what interests me as a business owner, because if I know why, then I get the wow. I discover this is why they buy. Let me do my marketing different. Let me adapt my product different. They prefer red color. Justin is more into red. He like four-wheel drive cars, not small cars. And why does he like that? Because he lives in this location, in this area, and there is less stable roads. You know, I need to find those elements that I need to code in my database. Now, the main objective that we want to abstract from this data that will give us maximum return on investment is we are mining. This is really a mining activity. It's data mining, but similar to precious metal mining. We're mining gold and silver out of our data. And I wanted to bring the two metals to your attention because often we only pay attention to gold. But in real life, when we mine gold, we find silver. When we mine silver, we find gold. And the ratio between gold and silver on Earth is 1:10. Natural ratio. And in my experience, a rule of thumb, the relationship between an intent and an action is at up to 10 emotions. There are 10 emotions that could have driven me to buy this car. There are 10 emotions or 10 states that have driven me to marry my wife. There is 10 reasons that I joined this company and this job. What are the underlying emotions? What are the underlying triggers that actually made me decide on that intent? Because if I don't have the underlying emotions and triggers, even I know the intent, I have a hard time to predict its crystallization with this market or with this person. And that's what we want to do, guys, is we want to understand that there is a relationship between the triggers, the emotions, and the intent. And we can link an intent to emotions, emotions to intent. And then we link the intent and the emotions to the why he's going to buy from us, and now we have a reverse perspective into finding our markets. Because we often understand very well, Zach, in the classic way of doing business, we understand the analytical way. We buy data. We say, let me buy data about the socio-economic data of who are buying Porsche cars or Mercedes cars in America. I want to understand. So I buy data and I go from the analytical way and I try to find the demand and then understand my demand. This is the classic way we know. The less classical way is this other way that we want to share with you, is that when you come from intent and emotions, and thanks to AI, we can discover intent and emotions and then go the other way around from triggers and data semantics back to finding who is our best customer, because we have data. And we notice that our best customer is actually a family guy that lives in a rural area. We didn't think about it, but those were the underlying emotions, a sense of fatherhood and responsibility, and a sense of guarantor, protection. That's why he went into a rural area, I don't know, or gardener. They love to grow their own food. And that is why he's going to have that intent to buy a four-wheel drive car, because it is now a necessity. It's not just a pleasure. I hope this example makes sense, but this is really the opportunity we have to also offer to our customers and ourselves to create and do this effort of creating this abstraction level database structure, because I know that intrinsically I may not benefit from it right now, but in 1 year, when I have more depth of data, more people, more endpoints, more enrichment, there's going to be a point where I'm going to be able to trigger my AI model, ChatGPT, Llama 4, Llama 5, and I'm going to be able to tell to my AI model, this is my database, this is everything I have. Help me understand why would customer buy my product, when, how, at which level, in which manner, and tell me where I can find my customers. You AI have all the data now. Go and fetch this for me. Give me predictive analysis, predictive targeting. This is what we can do if we do our job right, guys. So I'm right on time, 1 hour, right on the dot. I hope I didn't go too fast. I hope it's not too uncommon. But let's open the questions and answers. Eli, please, again, requesting your help.
Yeah, no, I just want to say, great thing that you pointed out is having clean data, which is really, really important. When you're bringing your data together and you scraped it, it's very important that there's no anomalies in your data. So, for instance, dates coming in, making sure everything's consistent rather than inconsistent date formats, for instance. That's the worst place you want to be in. I remember doing a project, what was it, about 15 years ago now, and I was transferring one database to another, and I thought, oh, that's all right, you know, I've just got an anomaly in this one column, and it ended up with something I could have sorted out at the beginning. It would have taken me 2 days, ended up taking me 3 months after converting one database to another. That's the difference that makes by not having clean data. Consistency, that's what I mean. And
yes,
if you are going to have some errors within your data, I hope the errors are consistent too, because you can always transfer consistent errors. So say, for instance, you had a date, say, for instance, the error says PST at the beginning of the date, which doesn't make sense, but because it says it all down the 1 million lines, it's easy enough to take the PSD out of all of them. If you have inconsistent errors, that's a nightmare. So I'm just saying it's very important to make sure it's easy to get excited, scrape your data, and then turn it into something else. First of all, make sure your data is clean, consistent, and how you want it to be.
Yes, no, thank you, Eli, and you remind me before we open to other questions, before I forget. What you mentioned is 90% of the reasons of data migration failures. Many businesses and our customers, they are locked into old legacy systems. Sometimes they have Windows, Windows, whatever, you know, MS-DOS, old system, and you ask them, why didn't you move? They say, too painful, too many mistakes. We stay there because nobody was able to actually create a database structure that can have a level of abstraction that can take the mistakes and the anomalies of the old data, match it to the new data, and create a temporary bridge. Let me show you what I mean by temporary bridge. You see here, we thought with the team, when we're going to present data abstraction to our group of good AI agency people, it's going to take a little bit of time to sink in our mind, right? So we as a team, we thought, let's prepare a bridge in our database structure so that my database structure is gonna talk to the old system, talk to the new system, and translate in between these two systems. So, for example, if it's too complicated for you right now, Eric, to deal with the abstraction level, no problem. What we've done is that inside the natural person, we recreated the fields that will prepare the abstraction. So for example, here we put temporary organization relation name, temporary relation starting date, and we said temporary because we want you to remember that this is temporary. Later we can design a bot or an intelligent flow that will come and take here the easy entryway that you did and will create for us the proper party without our brain breaking up. So here, Eli, this is the exercise, the added value that we can come and we sit down with the customer and we understand the structured errors, unstructured errors, and unstructured data, and tell them this is the gap. We know that it's going to take 6 months for your teams to be trained on the new abstraction database layer. In the meantime, here are the fields we're going to create to allow an easy transition for your team. So I hope it makes sense, Eli. But thank you for the opportunity to bringing this to the discussion.
Anybody got any questions?
Yes, and
I mean, you're such a good teacher. You're getting better that nobody's asking anything nowadays.
No, that's worrying.
Because you're so clear.
No, Mog, I see is here. Mog, please don't be shy. Mog is actually our teacher. He knows so much more.
Ryan's up his hand, so
yes, please, Ryan. Yeah.
So I've got a clarification question, just to check my own thinking on what you said versus what I heard. I'm comparing what you just presented to the database schemas that we've already prepared.
Yeah.
And am I thinking correctly that the difference between sort of the old approach and the new approach in terms of the abstraction layer is instead of just creating the relationship between the tables, that you're creating a separate table for that relationship? Is that the key distinction, or am I missing it?
That's actually, look at it this way. Your existing tables that you have, whatever it is, student, teacher, or whatever it is, it's already 3 tables at least. Teacher, student, and then relationship between the two. So now the same, we add another 3 tables on top. And now this 3 and 3 becomes a pair of tables. You could look at it like that. The abstraction is almost like a mirroring. It's a mirror. It's a less human semantical mirroring of what you already have in your mind, Ryan, in your table. And this mirroring of your human tables are really made for the AI. And that's why they're so weird. For us, they're weird. And they may look unnecessary. But if you understand it, even if you don't understand it right now, Ryan, if just you plan them and you put them there, and as you go, you feed in data, at one point, you will connect the dots in your business, because at the beginning, we may not need that level of analytics. But in 1 year, and we have 1 million data rows, things will start to appear and ideas will start to come and say, oh, wait, what if we pull this data and this data? What kind of semantic can we get out of it? So I hope it makes sense, but that's the best I can find, is really a mirroring at this moment.
No, I appreciate it. I connect and resonate immediately with what you're saying in terms of the power of the gold and the silver, in terms of the why and all of the emotional data points underneath that, and the granularity of data on that is powerful from a contextual understanding and identifying potential target standpoint. So
Exactly, yes.
I'm with you 100% there. I was just trying to think through the actual database structural change there. So thank you.
Yeah, so the good news is that because it's an abstraction layer, you don't need to break your existing tables. You just need to think with the team, with Leo. We have this now. How can we create the abstraction layer? And how can we link the two? So it's a bonus. It's not how you say in English. It's not an intrusive change. It's a complementary change.
Right. Excellent. Thank you.
You're welcome. And Eric, I saw a small notification. You said I could use the example, your database as an example. Yeah, I will.
Yep.
I will definitely jump onto that. But let's see, Eli. Yes, please.
Yeah, Zach has said something about what is the best way to give you the best chance of having clean data. To start with clean data, what is the best thing you can do from the off to give you the best chance to have clean data? That's what he's basically saying.
So it's a very good question, and it's a very good opportunity to use Eric database right now. So I'm gonna reopen it big to show you. I mean, it's just a proposal from our experience. You guys can take it in a different way, but let's say here is the reality. When we start acquiring data, whether you scrape the data or, sorry, this is also something that we will show you later, but let's go back into table view. Okay. When you start to gather data, at first, the data is in a tabular format. And when we start Zach, we may brainstorm with our team, and the best we can come with is assumptions. We're going to come with assumptions that, oh, we need to get the birth date, we need to get the address and the zip code, and we need to save a PDF of their ID, and this and that. But you have to remember that we do not know yet. We're just making assumptions about our tables and the data we want. Definitely we're missing something. Definitely, even if you're the smartest guy in the room, we will not get it right. But there is a way that we're proposing to you. Sorry, Zach, I couldn't hear you. Yeah, so any one of us will miss something, and our brainstorming will make it better, but definitely we can't know the future. So how can we be future-proof in our mind is, I'm going to show you how we did here for Eric and with Eric, is that, let's say this company, Yoga Studio. We scrape data. There is data that is normalized, like the location, the keywords. No, let me take another example that is a bit better. Sorry. It's actually an organization now. And I'm going to stop the search. So if I take... Yes, this is a better example. Yes, perfect. Is this big enough, guys? Yeah? Okay. Yeah. So data is alive. It really has a life cycle. When we start on day one, when we scrape, for example, here with Eric, this is what we could find on Google Maps as a first data set is company name, and we call it initial scrape because our journey is going to move from the initial scrape. We got the website, then we're going to scrap the website. We're going to enrich the data from the website URL. In the website, we will find their social media. Then we will scrape their social media to gather more information. From the social media, we will find other data points. Then we're going to use an API to enrich. And then we're going to use paid API, free API. And then when we exhausted all these sources, we're going to do a deep search with Llama 4 or ChatGPT because I want to go deep in understanding this customer. And then when I exhausted the AI deep search, I'm going to put a human to go and find me some more valuable data points. So you can see here, we just want to open your mind as to the different levels of enrichment that we may go through. We don't have to, but we better plan for if we want to offer the best to our customers. So it's already coded in our database model for you guys. Now that I understand that I'm starting small, you need to realize we're starting small with the best we can discover at the moment, with the best level of assumptions that we could gather as a team. No problem. we start with what you have. We got the category, we got the stars, how many reviews. We couldn't separate the address yet. So what we do is that we put the whole block of address in one JSON. No worries, we will deal with it later. But let's capture whatever we have. So when you see JSON, it's actually JSON-B in the database. JSON-B is a new data format that is very friendly to AI. It allows the AI to understand semantically a blob of text. So let's say if I throw the whole resume of a person here, and I call it resume blob or resume JSON, it doesn't matter. I don't know yet which university he went to. I don't know yet which job he got. I don't know his age. It doesn't matter. I don't need to code it. I just capture it, Eli or Zach. I put it in this blob JSON. Later on, the AI will be able to extract for me all the experiences, all the jobs he got, all the university's degrees, the date, the diploma, and he will put it into my normalized data field. And later, Zach, I will realize, damn, we forgot to create a field for diplomas or certifications. We forgot, but no worries. We captured the whole thing in the blob. And the AI is going to help me now get it from the blob out into a normalized field. So now, Zach, I will not miss the opportunity of the things that didn't come to my mind in the early phase of capturing the data. But I get everything from my customer. Give me your resume, give me your passport, give me the thesis you wrote, give me whatever. Just give me. It's private. We don't share it. It doesn't go to the cloud. I can serve you better. Let me scrap his LinkedIn. I'm going to scrap all his jobs because at one point I'm going to understand something why he quit that job. Or is this profile spending only 3 months in every job? I want to know if this guy is not stable because he only spends 3-4 months in one relationship. But I am not capable, Zach, right now to deal with the LinkedIn data. I just take the whole LinkedIn blob and put it here. Later on, I can leverage it. Sorry, Zach, you're on mute. Do you hear him, Eli? No, I think, Zach, it's on your side.
Yep. Zach, if you
worst
just
case,
look at the arrow next to the mic, maybe you need to change the input. Maybe that's the issue.
JSON-B, yes, you did well. Yeah, I said JSON-B, like Bob. It's a new format that we actually, Eric, you have this format already in your database. So PostgreSQL is a fantastic database. We will do a session just on PostgreSQL. PostgreSQL natively accepts JSON, which is the classic JSON, but the classic JSON is very hard to get semantics out of it and structure the data. But JSON-B, you can throw in stuff. And you can get semantic out of it, even if it doesn't look structured to us as humans. But JSON-B for an AI model, they're able to structure the data. They're able to recognize a date for that job, even if all the text is bundled together. This is super powerful, guys, to understand, even if we're not developers. But just as a business guy, I know that it doesn't matter if I have a blob of text. Let me capture it because I know the AI will help me understand it. That's level 1 of having future-proof semantics for us, is that we created fields that we just call about, about my customer. Whatever I get, I throw there. From LinkedIn, from Facebook, from a PDF, I just throw it there. And then there is another level, which is here. I didn't activate it, but we have documents, like the logo or something. I just throw the files here, and then let me show you here quickly. I don't remember if I did it here, but we have now I forgot. Sorry, I didn't activate it here, but I have it somewhere. 1 second.
But there was documents.
There was documents, and also, yeah, I saw documents somewhere here. Documents. Here, documents. Yes, very good. So maybe now, Eric, you don't need documents, or you think you don't need documents. Yeah, Zach, actually you will get this as a master agent. So like Eric, you will get the whole infrastructure, either as a demo or to run your own business. So this is super important for you guys to understand at the business level, is that, let's say I have I have a customer, let's say Eric, you're my customer here. And you gave me some documents. You gave me a video of your diploma celebration from your university. I find that video. I find the video of your wedding, and I find the video of your holiday in Cuba. You know.
Creepy.
Yeah. Or I don't know. You told me your preferred movies, your preferred song. I have. Let's say you allowed me to have media about you: PDFs, photos, sound, text, links, URLs, movies, whatever it is. The power we have today with the hardware coming in, Justin, you know, the new hardware, the powerful AI computers, is that I can transform as a document. It can be anything, a sound file, a movie file, a picture. So let's say I have a picture of you fishing, Eric. You're fishing. It's a very specific type. It's a lake or whatever, and you're fishing with a specific technique. So when I get the image, I have zero text data, right? What I may have is the date of the photo and the location. You tell me Lake Constance in Germany, summer of 2021. Maybe that's the best I could get from you. But I don't know it's about fishing. I don't know what kind of fishing. I don't know if it's sweet water, salt water. And there's so many data that I don't have. Now, what I will do is that I will send that image to Llama 4 or Llama 3 on my computer, and I'm going to create a vector. The vector is, the AI is going to be able to understand the scenery, the summer or the winter. It's going to understand salt water versus sweet water. It's going to understand the type of nature, the type of trees. It's going to understand if it was daytime or nighttime, it was cold or hot, it's fly fishing or that kind of bottom fishing, you know. It's going to give me so much data from that image. Yet as a human, I didn't use my brain. Now this is what we call vector data, and this database has embeddings for documents. So I can structure the date of the document, the title, which is the file path, the status, the date it was created, the metadata. But I can structure the semantic of the document that me as a human, I am not able to extract. But I'm going to give it to an AI. It's going to give me back a vector. The vector for us, it will look like 01100001. It means nothing. 929252.952. But in the future, we're going to be able to do RAG, retrieval augmented generation, where I'm going to ask, I can build a chat for my customer that I can say, find me what is the passion of Eric. Yeah, I don't have it in my database. The AI is going to go into the vectors. I'm going to say, Eric likes fishing, this kind of fishing. And he fishes in summer. And he likes to fish in nighttime because it's different than daytime. So do you see now the level of depth we can go? The brands, the tools,
the brand of the rod.
Yeah. Exactly, the rod, the length of the rod, the colors, whatever, you know. So this kind of data was not available to us a couple of years ago. We would not have been able to dig this level of data. But now if you guys understand that we can vectorize the data that we cannot understand yet, now Zach, you have the complete potential of monetizing and utilizing the data of you and your customer. So even if it's not for us, it's for our customers, like Justin, for example. If we were working with medical doctors and they have, how you call it, X-ray of lungs, you know, and they may say, no, no need to put this in my database. No. It's usable. Because one day you're going to want to ask the AI, find me all the people who have a problem on the left lung. You will not go as a human and open every image and break your brain. The AI will go and tell you, left lung with this kind of pathology, you have this customer and this customer and this customer. So I'm trying to give you this example. Let's say a car rental example. You know, when you bring back the car, they take photos of the car to see if there was a damage. Let's say you have a conflict with the customer. I vectorize the photos, and then I want my AI to audit because this customer refused and he said, no, it's not me who bumped it. And I have the vectors of before he rented it and after he rented it, and I asked the AI, find me all the customers who lied in their reports. They said that they didn't bump it, and actually now we have a workshop bill. So for all the cars who got a workshop bill but we didn't get paid by the customer, verify my vector image and find me the liars. So I'm trying just to open your mind, guys. So much potential. So I hope it makes sense. And you can put the contracts, because then you want the AI to comprehend the responsibilities with that event or that vector, because you want to say who is faulty in an accident. Here is the photo of the accident. Here is the document that driver A did, driver B did, and I'm an insurance company, and I want to understand what happened, and I have vectors plus my database data. Now the AI is going to serve me much, much, much better, or serve our customers much, much, much better. Now,
Mohammed, we got William that wants to say something.
Yes, I have one last point. Now we have a strategy, Zach and Eric, is that we know that we will not leverage this at the beginning, but in your database, you will be constantly moving data from blob JSON and vector into custom fields as you improve your business. In 1 year, you're going to create a new column because you noticed, damn, we didn't capture this. Now I create that field. Now I go back to the JSON, I go back to the vector, and I pull the data from that messy unstructured data, and I put it now in my structured data field. My database is future-proof, and I don't need to go back to my customer and ask them stupid, redundant questions. I can pull it off myself.
Before William goes.
William, go ahead.
Example. Oh, hold on. Just the example for the unstructured data. We have a shop, and we don't know we have a shop for children's toys made out of wood. And we are not asking our customers when is the birth date of your child, because most of the customers don't want to tell you. But most of the customers are buying before the birthday. So in maybe 30-40% of the cases, they ask, where's the shipment? Because on Saturday is the birthday.
Yes.
So with that method, we could load up the orders from the customer with the emails and connect the dots and have AI filter out the birthdays from that child. So in the future, we could have recurring, I don't know, newsletters for them for each birthday, for whatever, maybe even offer products that are suitable for the next year. Stuff like that.
Exactly. And let's dive on that example. Imagine you want to figure out, they don't want to give it to you, but you want to serve them better. So let's say the customer gave you his Facebook and connected with your business. That means that they allow you to see their profile. Now we could launch a bot from RTILA to go and scrap their public data. Imagine now there is a picture from his child with a birth cake and the date written in OCR in the image, 24 April 2029, it was the birthday of Jimmy. But it's not in text, it's in the photo. If I had vectorized that, the AI is going to be able to tell me, Mohammed, the birthday of Jimmy is the 27th of April. Does it make sense?
Yeah, so rethink what you posted online.
Yes, this is dangerous, but so powerful in a good way as well.
Yes, and the thing is, they've been using this for years. You remember when you're online, you go, how did Google know that I've just spoken to someone or I've done something just now, are totally unrelated, and you've come on the computer and literally seconds later, there is the thing, right? So we're getting the technology now, but they've had it for many, many years. And if you go back to how you felt at those times, we're now in a position to do the same thing what Google, Amazon, and all those others can do. We can now do that.
And look at the other context. We have a customer, it's a company. They have 1,000 employees, 100 cars, hundreds of computers and assets. tons of papers and photos and events. It's their data. It's their proprietary data. They have the full right to get the semantic out of it. We can give them total semantic on their data. So no need to privacy and so on. It's their own data. So it can work with public data with the plus and minus, but you can work on completely private data. And the magic of it, Justin, for your case, is that we do not need to expose our customer data to ChatGPT or Claude. We don't need to put their passport, their events, their personal data, what they buy from us, how we deliver it. We do not share that with cloud AIs. We run it on the company computer and we leave it there. We're just serving them. So, and this is the powerful edge that we can offer. Okay, guys, I hope I'm not confusing more than bringing clarity. But we can do a second session.
William, do you want to speak now?
Hi, Mohammed. Thank you for the section. So it's a great reminder to initially set up the data correctly.
Mm-hmm.
From my understanding that when we are scraping the data from the public and then using RTILA, using our software,
mm-hmm.
and then the endpoint, the destination that we're going to store, probably we're going to use the Google Sheets as an endpoint, right?
Yeah.
And I saw you use the open source directives as a database. So you're gonna from the Google Sheets to the directives. So you're gonna use another processing from RTILA, or you're gonna use AI to ultimately put the information to directives.
That's right.
Storage for our data.
That's right. So for every master agent, we take a VPS, a server for you. We install these directors with. So directors is not the database. Directors is the layer, is the content management system layer with the API that goes on top of the database. But the database is independent. You own it. So that if one day you say I don't want directors anymore, then you can remove it and put another layer. But we just got 3 weeks ago a partnership with Directors. We are an official technical partner, which is super cool. And Directors is free to use until you make $5 million per year of investment. Yeah. So and they will provide us technical assistance, and we have already developed an RTILA command for Directors, so we can push and pull data into Directors and PostgreSQL.
So we can do directly from RTILA to
that's right. Directly, yeah. Boom. When you scrape, you send it straight to Directors to the PostgreSQL. This is what we're doing with Eric. It goes from Google Map to Directors immediately. We don't use files anymore. He doesn't have messy CSV files and many Google Sheets. I think you feel a bit more free.
It's amazing.
And
that's awesome. Good to know.
Yeah, and this way we can also resume. We can pause automations. We can resume them, and now we can go to the million data sets. We can scrap 1 million rows because we have the structure that RTILA can talk to, pull data, push data, and then we build a system around it. So yes, well done for spotting it. It's Directors. The underlying database is PostgreSQL, and we set it up on a Linux Debian server with minimal security exposure. We only installed the minimal Debian Linux distribution, so it's very secure. It has SSL certificate, a lot of security, and so on. So it's secure, private, and it's certifiable for SOC 2, HIPAA compliance. So that if our customers tells us, I need the HIPAA compliance, I need the ISO security compliance, say no problem. The infrastructure is friendly for certification. Of course, we don't give them the certification. They have to pay us to get the certification. But at least our infrastructure is readily certifiable with user access rights, security backups, and all these things that certifications they ask for. Justin, any question? Please don't be shy.
Thank you for the info.
Yes, William. I hope I answered your question.
Yes, you do.
Super.
One question I have.
Yes.
Can we get access to these slides? Because I didn't record this meeting.
Definitely. So again, we are still building our internal section for our program, and we created a folder, Google Drive, which we will share with you all the presentation. And Master Agents, they get the editable version, because you need this to go and also sell and explain to your customers. So you will get the editable version, and the other members, they will get the PDF version at least, plus the recording, the video recording. And Ryan, yeah, sorry.
I was just going to say, when,
yeah, Justin?
Pardon my anticipation, but I'm
Sure.
very eager to get access because I want to learn more and I want to practice on directness and just get moving as quick as possible.
So in the coming days, we will send the video, the PDFs, the PowerPoint, and also I forgot to tell you guys, we share with you regular agent and master agent, and regular agent that do it themselves. We share with you the database schema, the files, and also the containerized file to install it on your own server if you don't want us to do it for you. You want to do it yourself, or William, if you want to now do it for your client without having to pay us or rely on us, we will give you the templates to install it yourself and play around with it and resell it. So this is all. Our approach is to empower you with the knowledge, the tools, and transfer the knowledge to you and the infrastructure so that you can then sell it and transfer it to your own customer. That's our philosophy. Justin, are we good for your questions?
Yes, thank you.
Cool. I think Ryan had the hand raised.
Yeah, piggybacking off the same question is I was unable to miss last week, and I would like to rewatch this one also. Is this being recorded, and will
it is?
Master Agents get a video or no?
Yeah, you will get it. Sorry, we were late. I burned my 2 computers, but we have last week recording and this week recording. We're gonna publish them at the same time. So
okay. And where is that? Is that published on YouTube or is that?
Yeah, it will be on our YouTube channel. It will be on our YouTube channel. And okay. Some videos are private, so some videos will be sent to you guys by email. And those who are public will be made public. And also, guys, remember that before we publish this, any one of you can tell us to remove some part. If there is anything that you don't like Eric, if you want to blur the URL or whatever, you know.
I'm good. No.
Okay.
It's all right.
And thank you, Eric, for allowing us and being open to share your own progress with the team, because I think it gives a real first-hand example of how this can crystallize.
You didn't show the map though.
Oh, yes. Can I? Let's do that. So the good thing about when we scrape data and we prepare the structure properly, we can create multiple views easily. So for example, when we were scraping the Google Map data, sorry, my computer is very slow, but let's go into organizations here. With directors, we can do a map view, and I hope we didn't lose the map view. And now, not only we scrape and we know what they do, but we know where they are. And the good thing about this technology is that without spending money in development and spending money on a software, this is free, and we have integration with RTILA. I now can see the data that I scrapped in a geolocation friendly way. I can cluster and I can decluster, and now when we did this view, then I got what Eric was doing, because at first he told me and I didn't get it. He was telling me, I think you were telling me at the beginning, you're scraping these practitioners in 2,400 cities in Germany. So I just heard.
I went to just my approach. I went to Wikipedia and searched for how many cities are there in Germany. And there's a total of 258. So of course,
200 or 2,000?
2,058. I'm sorry.
2,058.
So I multiplied that with my keyword, and then
you did all these search URLs on Google's for because you're getting villages. I was thinking, what is he doing with villages? I didn't get it. So when we put the map
but here in this list, it's just a limit of 1,000. We have 14,000 already scraped. So
that's good.
We don't want to.
Yes, so you can, I think you can change it here, but yeah, so this is so powerful. And if you have data, if you have dates, you can also have a date view, a calendar view on your same data. And then you can go and, for example, the date of hiring or the date of whatever. You can also have calendar view. You see here, this was scraped on the 9th, these were scraped on the 10th. This is another way of approaching your data again. And then depending, if we are doing lead generation, I can go into Kanban mode, and then I want to move my, so Justin, this is your case. You can transform all your data into Kanban-like without having to pay Trello or another system, and you offer it and you embed it for your clients, and then you move their teams, they move the conversion from one column to another.
All three of those options would be working for the use case, because I could have the map view to see where the nurses and doctors are nearest to the patient. The calendar to see when the patient was admitted and how much time until they need to be seen.
Yes.
And then or to move them across with all their details.
That's right.
So
Let me give you one more perspective, so that also not only you, but also our people can get more. Actually, it's applicable for almost all of us, and I think Mug, this will be good for you. We can do even better. Let's say you want to know who goes where in an area, right? So for now, I created just, this is called a single dot, which comes as a longitude and latitude, but it's a single dot. But I can create in my database structure, when you talk to the customer, you can tell him there may be different ways of saving geolocation data, and let's not be focused around one dot. Let me show you what I mean. And here, Zach, this comes again into our brainstorming. If I say an organization, now sorry, let's take a human. We have a human, which is a doctor, a nurse, a plumber, an electrician. They may have a zone of activity. So it's not a dot, it's a zone, right? I can code that with directors and with RTILA. So I can create a new field, and I go to the map type, and instead of a point, I am going to call it a polygon. And then I can draw a polygon of the responsibility area of this plumber. Yes, Zach, because you know that this plumber is doing this zip code, this zip code, this zip code. Now you can create an overlap, and the AI can understand this. That's the magic of this database, is that the AI will be able to tell you these two plumbers, they overlap by 50%. These two doctors, these 10 doctors, they're all in one area, and we have less density here. Because we have polygonal geolocation data, we have dot data, and we have line string. Like you say, we have these 3 clients who have a plumbing issues, and there is only one plumber. What is the best road? Should he go to Arlington first and then to Washington, DC, or he has to go back there and come back here? And the AI will help us to do that because we have the line string type of data. We have the dots, we have the multi-point, we have the polygons. This is so rich, guys, that we can leverage if we understand it at the beginning.
Can I just jump in just quickly?
Please, Eli.
Now,
Yes.
Now, glad, because I like to just take things in, say nothing, and then, but I'm quite creative, and this is massive because as much as you took in so little amount of data in real terms, you've actually exponentially expanded by 500% because the AI can see relationships and compare distances or difference in names or so on, all the information you didn't have before. It's just absolutely crazy with what you can do with this data.
Absolutely.
It absolutely blows me away.
So, but that's exactly what we want, at least to conscientize this weakness that we have as humans, because we are blocking the future of our businesses because we only think what we can understand. We have to forget about that. We don't understand much. Because
so the key takeaway with this really is to scrape as much data
exactly
that's related to it as much as possible. As Mohammed was saying, it may not make sense at the time.
Yeah.
But if you can scrape as much as possible, the AI can actually exponentially give you so much more information back with what you didn't have a clue at the time.
That's
and
right.
When you come to pin up the business, my God, it's just absolutely
yeah. So
crazy.
maybe like as a shortcut, we could say, no data is useless.
No,
it is only
all.
temporarily useless because you don't see you don't leverage a meaning of it. But at one point you may need that meaning. And let's address another point that people were using as a reason not to save extra data. They were saying, I don't have enough disk space. This technology is compressing data. JSON-B is compressed. I can have so much data, and then it takes me like a small text file. But then it gives me so much power in the future. Now, I'm not going to record the video and save the video, but the embedding of the video is going to be 10 megabyte. The video is 1 gigabyte. But the embedding is 10 megabyte. I saved the 10 megabyte that has the meaning of the video. I didn't save the video. But I have the story of the video, who people, what was happening. There was a car, all that is in the vector. Now that vector, I can leverage it in 3 years, 4 years, So we don't have the excuse of this is too much data to save. I don't need it. Privacy. No, if I have access to the data, let me put it in the database as a blob. For now, it's okay.
Sounds like a Google board meeting here.
Yeah. No, I mean, I think the English word is we need to recover all the opportunity costs that we have been missing and our customers have been missing. There's huge opportunity costs we have let go for years. Is it the proper word, opportunity costs? There was an opportunity and we didn't leverage it and it passed?
Yeah, cost of opportunity.
Cost opportunity, sorry. Cost opportunity. Yeah. Yeah, so we spent a lot of time, and it was, personally for me, it was very hard to understand this abstraction level. But then when I understood that the AI models will allow us at no cost, again, we removed the cost matter. At no cost, I can use Llama 3, Llama 4 to vectorize. Vectorizing is very costly compute-wise. I cannot use Azure AI. If I use Azure AI or ChatGPT to embed the vectors of videos and photos, it will cost me probably $50 per client. I will not do it. Now, if I have my graphic card and my hardware, and it costs me 1 hour of my computer, I will do it. I will vectorize that video for AiA. I will vectorize for every one of my customers, even if it runs for 100 hours. It's okay. Zach says step 3 and 2 is done in step 1. Yeah. Maybe there was a context to that. I didn't see the chat. But
just before, Zach asked if there are 3 points: scrape as much as possible, then import it into JSON-B, and then move it into the system for cleaning. Correct?
Yes, that's right.
Yes, but step 3 and 2 is done in step 1. So.
Yeah, you can look at it in different ways. But yes, I think Eli said it well. Gather as much as you can. Whatever you're allowed to gather it, store it in whichever format. The best is to compress and vectorize. For things that have semantics but do not have text, we vectorize them. For things that have text, we copy the text and we put it in JSON-B and it's compressed. So this way we don't miss anything. So I hope you can see the potential, and also I hope this can motivate you in putting a little bit more work and being a bit more patient in time as to when we're building this infrastructure. But we see a great future, a great benefit for all of us and our customers if we take this effort right now. Yes, Zach, I said Llama 4. 3 days ago, Facebook Meta, they released Llama 4. It's gigantic. So let me show you here. Very fast. 2 things that I want to close maybe on if we don't have other questions. That is the reason why we are at the best time in business history right now, I think, for this kind of shift. There are 2 things that are coming together. There is, we're at the consumer level, we're finally, you guys in the US will have access earlier than us to AI powerhouses computer at the cost of consumer level computer. This is $3,500. It's coming in the summer to the US. It has 1 petaflop. You know what is 1 petaflop? Is what we called last year a supercomputer. You know the supercomputer that only Apple had and IBM? Zach, you can have a supercomputer next month or in 2 months for $3,500. This supercomputer, you host it. Your customer can host it. Now, this supercomputer is going to do the embeddings for me at very low cost and very fast. This supercomputer can host Llama 4. And Llama 4 is a gigantic model that is being released open source and for free. And they have another one here, which has 496 gigabytes of RAM and can accommodate 460 billion parameters models. We will do a training on this, what it means. But what I'm telling you here is that the hardware is coming. The models has been released for free. This just came in few days ago. Basically, Llama 4 is the power of ChatGPT 4 hosted by us and our customers for free. That's the power that is coming here. And they have three levels to it. It's an amazing model. It's a model that can do video, sound, images, text, semantics, meanings, emotions, the whole suite. And this is what will enable our vision to come to a reality.
There's one question I want to ask, and it's something that Mog actually asked approximately 10 minutes ago, is the MCP server. He's talking about setting it up. Is that able to be set up? I mean, MCP now, I'm really drooling at the bit when it comes to that. Now, what's the status of using your software with MCP? Because that...
Yeah, that's a very good question.
Powerful.
So MCP and agents, there is a crossover sometimes. And also now you have what they call AI wrappers. These are softwares that use AI to do something else. And they present it like a software, but actually it's just a container that uses the AI, existing AI models like Claude and ChatGPT. You heard of Manus. You saw Manus? Did you guys hear about Manus? Manus is not an AI model. It looks like an AI model, but it's a general agent, AI agent. Manus is a wrapper. So sometimes you can call it AI agent, MCP, or a wrapper. So Manus is an operating system. It's an algorithm that is able to leverage Claude or ChatGPT and give it control of the Linux server so that it can open the browser, open files, save files, generate videos, and now it's like controlling your computer. It's like computer control. All this is coming. Now, this is a specific world that we are not well equipped for. But what we want to do is that we want to have a database and a business structure that can leverage any MCP, any agent, any wrapper, any AI model, because I have the database structure that can allow me to take ownership, and I involve the MCP, I involve the AI agent in the way that serves my business, and not they onboard me into the way that serves them to make money as an MCP, as an AI agent. I own the relationship with the MCP or the AI agent. Because this Directors and PostgreSQL has an API. So I tell them, this is my API endpoint. Your agent does that, your MCP does that. Feed it, pull the data from here, put it back here. Thank you, sir, and I will pay you $10 an hour, $1 per entry for your MCP, for your AI agent, because I control the input and the output, and then I get back the value and I save it. That's the way for us and our enterprise clients to deal with this big creativity that is happening at the MCP level, agents and softwares. It's like popcorn coming everywhere. But we don't abandon our data. We tell them these are the rules of engagement. Our data is with us. We structure the relationship, give us the added value, put it back here. Does it make sense, Eli? So let me show you very fast here. For example,
Meg, is that okay?
Yeah. Here in the system of directors, and we are developing an integration, there is directors flows where you can build automation flows like Zapier for free. So here you can call RTILA bots, or RTILA bots can call a flow, and this is data centric, it's not software centric. So my data, when something happens in my data, I can trigger something, separate first name from last name, missing date of birth, reformat date of birth. This is the database healing itself by itself with these flows. And these flows, they can call an MCP. These flows, they can call another API. This flow can call an AI model like ChatGPT. This flow can call Manus, you know? Eric, you started using Manus. So we can call Manus from here and use Manus and put back the data into our flows. And then this flow will put back my data in my table. And now I can use it for whichever way. And before I forget, what we're doing with Eric is that because the data is massive, and business people, manager people, they want dashboards. They often tell you, I don't understand all this tabular data. I want to see the transformation, the money, you know, the cost, where are the errors. Now we can build out of the box very quick small dashboards, and we can see that he still has a long way to go, Eric. Eric converted 4% of his total cities searches. Out of those 4% of search results, he got 15,000 URLs of businesses. Out of those 15,000 URLs, he already scraped 7%. He converted 7% that he scraped. Out of those 7% correspond to 1,000 business listings that now he has phone number, whatever, you know. And then he can look at, as RTILA bots are running, he sees this progress being made. Is that correct, Eric? I think you stopped the bot right now.
I stopped one, so the other one is running. But you can even refresh this dashboard at a rate of 5 seconds, 10 seconds, 30 seconds, 1 minute, whatever.
Exactly. So I think it's here, refresh. I can refresh every 10 seconds.
Yeah, if it's running, then you can see 15,605 URLs acquired.
Here, this one, 15,600.
Refreshes, it should jump pretty soon.
Yeah, it jumped to 625.
Oh, it's working. I even, well, Mohammed advised me to let it run safely with 100 URLs at a time.
Yeah.
I scheduled the project on RTILA to run every hour or every half hour, whatever. And then it repeats, and I can go to sleep. I can check in the morning, and it has done 8,000 overnight, whatever. And then you can start the next bot doing the scraping.
Exactly, and then you can launch another bot that do the enrichment, another bot that reformats the phone numbers. So you can have so many RTILA bots, other APIs working, and now we have, as business owners and for our customers, we have a way where we see our data being transformed and gaining value. And I think this is how you call it in English, self-rewarding for the hard work that we were doing in the darkness and it was not showing too much results. But now, finally, it's very enjoyable to watch. We went over time. Ryan, I don't know if you're still here, but I'm sorry for overtime. But maybe we can, if there is no urgent things.
This has been great.
Yes, Ryan?
This has been great. Thank you.
Superb. Happy to serve. Happy that we can exchange. We still can take another 5 minutes if anyone has a question.
Let me just, I try not to ask questions like this because I try to slow myself down because I like to scrape and scrape and scrape.
Yeah.
Realistically, using your software, how many bots could be scraped? Obviously, you have to use multiple.
Yeah.
You'll have to use multiple proxies, and the data's got to be and the server's got to be a certain power, etc. But how many bots could be used at any one time to be able to scrape?
Very good question.
How much data are we talking realistically that could be done?
So let's again go back to our philosophy. Let's not be bot-centric or software-centric. Let's be data-centric. So can I rephrase your question?
You can.
Yeah. Your question in our philosophy is, Mohammed, my data set, my database, not the software, not the bot, my data structure and my database, how much can it do? Yeah, I turn it around. That's the right way of looking at it. Now, because I come from a database perspective, PostgreSQL, what can it handle? PostgreSQL can handle 100 concurrent read and writes operations at the same time. 100 concurrent. That means that now that is the capacity of my architecture.
Okay.
To whom I'm going to allocate the concurrent writings. So let's say I have about 100 visitors. Let's say I have about 100 visitors per hour on my system I need to keep 30 connections for my public visitors, for my customers, because they're triggering my database. So I keep 30 for them. I have queries. Then my API can respond. I have 10 staff that are connecting. They're going to consume another 10 concurrent connections. Now I have half of my concurrent capacity gone between my staff and my clients. How many I'm going to use with Zapier or N8N or some system via API? Maybe another 10. Then how many I can afford for RTILA? Can I launch 10 bots? Because RTILA is very heavy writing. It can write like 10, 20, 50, 100 at the same time. So you have to understand how much you allow your RTILA bots and how many you run at a given point. But that's what you have, the bandwidth. So think at it as what is the bandwidth of data read and write that I have, and how best I allocate it to all the other systems. Because all the other systems are serving my data sets, not the other way around. And I decide who I allow, when, at which capacity to read and write my data. And this is what we need to teach to our customers, because if they do this, they're going to take ownership, a true ownership of all the processes.
Thank you.
Yes, I hope it answers that question. So you could have 20 RTILA bots, 10 APIs, 100 customers in an hour, and 10 staff at the same time. Now the volume, PostgreSQL can host millions and hundreds of millions of dataset rows. And we've built PostgreSQL with horizontal and vertical scaling. We have an extension, and we talked about this with Ryan a lot. We can demultiply the PostgreSQL on multiple servers and have master, kind of master slave or lead and extended, they call them database, secondary database replicators. So let's say you have 1 million customers. We just replicate the database in reads, and one database dispatches the workload to 10 databases. So this is super scalable, super scalable. Another partnership we did is on RTILA homepage. We got accepted by Quadrant, which is a vectorial database that is open source and self-hosted again. We can bring it to our customers here, Quadrant. So imagine you have a customer that has thousands of employees, and they scan thousands of pages and documents and videos, and now they have too much vectors, because PostgreSQL can only host about 1 million vectors. It was not designed for vector. It's good for the beginning, but let's say if you have massive amount of vector, then we bring in Quadrant as a vectorial database that comes with PostgreSQL. Now Quadrant database can take 10 million, 100 millions of vectors, which means we can grow to almost any company size, this infrastructure. It's hyper scalable.
What is the cost for that compared to, let's say, Supabase?
10 times cheaper.
Nice.
10 times. I think, Ryan, we worked on this a lot. Maybe you can give some feedback. Maybe 8 times, sometimes 10 times, sometimes
Supabase
5.
is giving 250 gigabytes for $25 a month.
That's right. This is a Supabase. This is more than a Supabase that we're giving to our agents and that you can give to your customer. This is the enterprise level of Supabase that they charge $700 a month. And they limit you in CPU and gigabyte. But here you put your own hard drive. You put 5 terabytes of NVMe disk. Nobody stops you. And no AI costs, no embedding costs, no retrieval costs. So we're bringing total freedom and ownership to our customers to deal with their data and give the maximum semantic meaning to their data, so that we can all make money. We're all making money from data, us and our customers. So
yeah, and that's
yeah. Yes, please,
and
Ryan.
that's where the major cost savings is. It's more than just Supabase. It's on the computational aspects that from what we've been looking at with Mohammed has made a much even greater impact in terms of cost basis or savings.
Yeah, definitely. And Ryan, when we were comparing the costs, so sorry, I'm gonna pin your video so that we can see you better. So what is very expensive, so we're in no way against providers like Azure and AWS. We love Azure and the AWS. What we're against is that using them in the wrong setup and paying crazy fees when we are not making money out of it. So the right approach from our perspective and what we studied with Ryan is that GPU compute is the most expensive. CPU compute is okay. I can host with AWS, I can host with Supabase, I can host with whoever, but GPU is extremely expensive. If I delegate my GPU compute to Azure or AWS, it will cost me thousands of dollars per month before I make thousands of dollars per month of income. I want to avoid that. I want to avoid stretching my expenses before I have extended my revenue. So the opportunity we're offering to you and our customers is, hey, why don't you buy this computer with this graphic card? Run it locally, crunch the GPU locally, and then delegate the CPU at a good price to AWS, Azure, or whoever, and use them as an extension for what is worth for you to pay them to do. That's our approach. We own the relationship with them, not we are owned by their commercial product. We have chosen to work with AWS. We have chosen to extend our database with Neon or Supabase because we have overstretched ours and we don't want to set up a new server. So I just rent new space for them for that 6 months or whatever. This is the best way to go with these providers from our perspective. We get the best of both worlds.
That's really good. Dr. Charity, as it's your first time, is there anything at all that you're scratching your head with?
Yes.
I know it's a lot to take on, so there may be something before we hop off. Is there anything at all you want to ask? Has anybody, we're just about to shut down, is there anybody got a last thing to say before we finish off?
I had one last thing or one last question. Let's say in my use case, someone, or we do find a client that wants to adopt the new SaaS.
Yeah.
But they want to move from their existing system. Is there a way to make that transfer of data, all the contacts into the new CRM, let's say, that maybe could RTILA automate that process?
Yes, that's a very good question. So again, we need to seal the context and be sorry, I'm trying to make your face bigger as well, Justin. Here. Again, data-centric, yeah? So it's the most feared activity in enterprise world. The most feared decision is migration. Data migration is so scary, super scary. Most of the time you're gonna find your customers telling you, we tried with, we hired Deloitte, we hired KPMG, we hired Accenture and IBM, and we will try to move to Microsoft Dynamics from something, and it messed up and we paid thousands and thousands of dollars. It happens very often. It's not a problem of intelligence and capacity because they had the best engineers. It was a problem of what we're talking about today. It was a problem of asking the right question and looking deep into the data structure and not being shy of saying, what is the life cycle of your data in 5 years? What do you have now? What are you missing? What are the formats? What about this? What about that? What if it stops? What if it starts? What if it breaks? And because we didn't do the BPMN, which you started to do, Justin, BPMN, business processes, Zach, you also started on that. Very deep BPMN, understanding the human business processes, matching the BPMN to the database structure. That's the secret sauce for us. When I have these two from my customer and I have talked to my customer, we can find those subtleties, those subtle breaking points in the data migration. And because we have covered them in brainstorming, then we do what we talked about earlier. I prepare my next database on PostgreSQL. I make it twice bigger to accommodate for the exact abstraction of the old database. And I create the new abstracted database in the same database, two databases in one cluster, so that even if we fail, the data of our customer is still available in the new format. You see what I mean?
Yes.
So we have not failed, it's a failover. And then we start to convert from the new PostgreSQL same database schema, and we convert to the new database schema, how you call it in English, without interruption, without shutting down one schema, one database structure from another one, and we can have two interfaces. They have the old interface for the old database schema, and there is the new interface with another URL. And you know what we had here in Mauritius is that they told us we're going to move the sales department to the new system first, because that's where we need to move. We need to make sales now. We don't have time to train our accountants and our staff and the customer support. We need the sales team to go first with the new system and the new interface. Let us do 6 months, 1 year, make money, and then we're going to move the others. And they're happy to pay for 2 hostings at the same time. It's not a problem, because we give them that business resilience, and that's the key. You need to offer them that bridge and that double cost, which is very small, but is worth that security for the business. And Ryan, you have the same situation. You're going to be paying 2 hostings somehow.
Well, we could talk about that. That might change based on this conversation.
Okay. So, but in any case, we could offer that. You can offer, in our experience, a migration is nowhere done in a month. Especially if you have 100 employees working for 10 years, that's huge data set. That you have to plan it on 6 months, 9 months, 1 year with concurrent systems just to be on the safe side. Justin, does this answer your question?
Yes.
Superb.
Essential. Thank you.
Zach, please don't be shy. And sorry, we still don't hear you. But if there is anything in the chat, I'm starting to get hungry.
So are you going to cook for us, are you, Mohammed? Because I'm hungry too.
I would like to, this is one of the skills that I have never been able to acquire. Really? I barely can do an omelette, and I don't even want to eat it myself. So no, I'm sorry. I'll invite you for good food. But I'll eat with you.
You mean you're inviting me for your wife to cook the good food?
My wife has the touch. She does beautiful stuff, yeah. I see. But yeah, I don't promote my own food, no. Sorry. My food and my drawings, I kept the same skill level as when I was 4 years old when it comes to artistic things. I draw the same tree, the same sun, and a house, and that's all I draw. So no.
Don't worry, it'll be worth something when you're dead.
Yes, but I will vectorize the recipes, and I will ask the AI to help me do the couscous.
Oh dear.
Yeah, so let's see the chat. Thank you, Zach. Thank you for your encouragement. Eric, he shared Calendly. This is your link, your Calendly link, Eric?
Yeah.
Yeah, guys, jump on the link. Eric is so resourceful, so nice. And you guys, I think we had sent an email, but we are soon opening our AI agency program community inside RTILA, where you guys will be able to talk to one another and exchange stuff. So it's coming up. Superb, Zach.
Mohammed, did you know?
Yeah.
Mohammed, did you know that you can take a picture with ChatGPT of your fridge and ask him what can I cook from it?
Oh yes.
So
yeah, that's super cool. So I worked on a project which was in e-commerce, where embedded cameras in the fridges, and Samsung fridges, they have that, and they have it's an IP fridge, and then they will order the eggs and the milk and the cheese from our e-commerce website with the delivery when you need more eggs and more milk. And so this is coming, and maybe we will be building some of this stuff for our customers. And again, if you have the right architecture with the right SKUs and the right photos of the product, so that the AI can recognize this type of eggs vs this from the provider, then you're going to match, and you can recognize French cheese from Dutch cheese or from German cheese. Okay, talking about cheese, I need to go and grab a big piece of cheese. But if you guys are good, we're going to thank you again for your patience, for your participation in the program, for taking our delays and our infrastructure building. But I think we are onto something that can be big. We will have the trial and error, but we shall get the rewards. Definitely the rewards will come, just a matter of time.
Totally agree. I hope everybody else agrees. That was a good session, actually. I learned quite a bit myself. Mohammed, thank you for being such a great teacher. It's so difficult actually working with you because hardly anybody wants to ask questions because you're too good a teacher.
No. It's not that I'm a good teacher, it's that I'm an eternal learner. And that's exactly what we should be. We have to keep learning and challenging ourselves that there's new thing coming in. I want to know how this is working and how it can benefit my business. Guys, thank you very much. So please book this on your calendar every Thursday, 1 p.m. Eastern Time, and we see you on the next Thursday. Enjoy the evening. Sayonara. Good night. Salam alaikum. Shalom. Bye, everyone.